Alright, welcome back guys. This is question number 47 of the Find the Limit problems of section 3.3. This one, the first time you try it, it's probably going to seem like a incredibly difficult problem, and after a couple times it'll seem a little bit less BS and you'll probably be able to laugh your way through it. So let's jump in. There's two things you basically need to know. One of which is, well, what is it asking for? The first thing is it is asking for the limit as t approaches 0. A direct substitution doesn't work, you just get 0 over 0. So there's basically two tricks to solving this problem. The first one is that if you take the limit as x approaches 0 of sine x over x, it's equal to 1. And this also holds true if it's flipped, because if you think about it, if you have x over sine x, right, you can just flip it upside down by raising it to the power of negative 1, and then you can apply the same limit and you just get 1 to the power of negative 1, which is just 1. So basically, that's kind of the first thing. The second one is that you could replace x with 3t. So anywhere where you see an x, you could just replace it with 3t, and the limit is still going to be true because it's just a variable. So this limit, for example, this basic substitution here still works. And if you look, this sine of 3t over 3t looks a lot similar to our original problem. So now that you know these basically two limits, one of which is that if you have sine t over t is equal to 1. The other one is if you have sine 3t over 3t is equal to 1. And if you flip it, it's still true. We can jump into our problem. We're going to use all three tricks here. So the first step is we can separate this limit into two parts. So let's go ahead and do that. So all that I've done is I basically made sine of 3t over 1 times 1 over sine t. And as you can see, it's basically the same problem. It's just been separated out into two parts. So let's just look at the first part for a couple seconds, okay? Does it look like the identity that we established? So I put the identity that we established on the left and what we have in our problem on the right here. So I bolded what's different. Can you tell what it is? It's basically the 3t on the bottom is missing. So just a quick question for you. How many times have you seen a variable in the denominator and a numerator, or the top and bottom, and to simplify it, you just kind of cross it off? So if you look at the first step here, you have 6z over 3z, and I'm just crossing out the z, so it gives you 6 over 3. Then just for fun, I multiply it by y over y. Yes, I have a strange definition of fun. And you just get 6y over 3y. And I could cross it off again, and I go back to 6 over 3. And all these expressions, they're all equal to 2. It doesn't really matter what I choose for y or z, because there's one on the top and the bottom. They're going to cross off. And the whole way through, every one of these values is equal to 2. Right? So the interesting thing is that when I multiplied by y over y, it didn't change the value. Because basically y over y you can think of as being the same as like 3 over 3 or 4 over 4 or multiplying by 1. It doesn't change the value. So I'm going to use that trick here, and I'm basically going to multiply the top and the bottom by 3t. And the reason I picked 3t is because when we look at our version on the left, it had that 3t on the bottom, and I wanted to make a 3t appear on the bottom like a math magician, just pulling it like a rabbit out of a hat. That's a trick you're probably going to have to use all the time in these stupid sign limits, so keep it in mind. Okay, so there you go. Now if we put that back into our original equation here that we had split apart, it's starting to look a lot more like our identity. The only difference is that we have like that 3t that I bolded to indicate we still got to deal with that. So wouldn't it be nice if we could just move it somewhere so it looks exactly like our identity? So where do you think we can move that 3t to? Well, we can basically just move it across. Because the same way we sort of split it earlier, because it's a multiplication, we can just multiply that, move that multiplication of 3t on the left onto the right, and just times it by that 1 there. So, yep. Now basically the next step is I'm going to apply the limit here. So basically where we have the identity, I'm just going to replace it with a 1. So that's pretty self-explanatory there. Now the second part, it kind of looks like the limit we need, so I'm just going to take a 3 out to start with, right? And then I'm going to do a little barrel roll here to pull back an old meme. And when I do that, basically I'm flipping the t on the bottom and putting the sine t on top and raising to the power of negative 1 because it just works. Alright, so here we go. We're going to basically apply this limit one more time here. You can see that the limit we have in what's left of our question looks just like this limit here. So I'm just going to replace it with 1. Of course, the limit is raised to the power of -1, so I have to raise that 1 to the power of -1. But 1 to the power of -1 is still just 1, so it doesn't change anything. And so 1 times 3 times 1 just gives you 3. So if we're going to be really explicit, I would write the original limit again and say that it is equal to 3. And so that's how you solve this problem. There's a lot of weird algebra tricks, like you have to kind of have the intuition to split it, and then you kind of have to make numbers appear out of thin air. So the first couple times you do these problems, it is kind of confusing. But after you do them like 3 or 4 times, the difficulty is going to decrease a lot. But you do have to practice it at least probably like 3 or 4 times before you get it. And try not to be practicing it on your exam. That's my advice. Anyways, I hope you found this video helpful. If there's another problem you'd like me to solve, just go ahead and leave a comment down below with the section number and question, and I can jump ahead to that problem. Otherwise, I'll probably just keep solving these in order. And if you're working out of a different textbook, my email address is in the description. You could always send me an email, and I would be happy to help you guys out.